Yeah, we are live. We are live. So we are going to discuss some good questions, some 20 previously asked PSU questions from the concept electrical machines, from the subject electrical machines, from the area transformer. Especially, I'm going to discuss today transformer. If you have any questions, you can ask. If you have any questions, you can ask in the chat box. Okay, in the chat box, if you have any questions, you can ask. See, from transformer in the HPCL examination, at least I can say 5 to 6 questions will come, at least. This is not from my own theory. This is from previous paper analysis. If you analyze 2021, 2022, 2023 papers of HPCL on transformers, minimum of 5 to 6 questions were given. So that much importance transformers is having. See, transformers, and I can say synchronous machine, induction machine, DC machine, entire I can say overall machines. If you take, the first priority goes for transformer. Fine, the first priority goes for transformer. So this is the first question. Read the first question. Yes, you can answer. What is the first question? In a single phase transformer, the kVA rating of the secondary side is, we all know that transformer is a constant power device. If we neglect the losses, primary side kVA is equal to secondary side kVA, or LV side kVA is equal to HV side kVA. See, in most of the cases, we write this one. We write this one, that is V1 I1 is equal to V2 I2 for a transformer. For a transformer, we write V1 I1 is equal to V2 I2. So let's read the options. This is the, see, all the questions what I'm taking are previously asked PSU questions, not my own questions. Why? Because if I take this much simple questions, people may get one doubt in their mind that sir, you are discussing very simple questions. Why? Why? Because depending on the level of examination, depending on the previous papers only, we will be taking the questions, right? So what is the answer? Half of the kVA of the primary rating side? No. 1/4? No. Same as the kVA rating of the primary side. Same as the kVA rating of the primary side. Option number 3 it is. Let's go to the next question. Yeah, it's a good question. It's a good question. It is about I think efficiency, maximum efficiency. So that is a good condition for there is a condition for maximum efficiency. Let's read the question. What that fellow says. What that fellow says is saying a 2 kVA transformer has iron losses of 150 watts and full load copper losses of 250 watts. So that fellow saying iron losses is equal to 150 watts. We all know that iron losses of a machine are independent of load. Iron losses are going to depend on voltage and frequency. In fact, flux, Bmax, I can say Bmax, maximum flux density. Okay, iron losses. What iron losses is having again two components. One is hysteresis loss and one is eddy current loss. Iron loss is having two components, hysteresis loss and eddy current loss. Okay, hysteresis loss and eddy current loss, they're having their own formula. Yes, we'll see. Okay, so iron loss is 150. Full load copper loss. Full load copper loss is equal to 250 watts. 250 watts. The maximum efficiency of the transformer would occur. That fellow is asking maximum efficiency. Maximum efficiency. Maximum efficiency. Okay, when maximum efficiency is going to occur? What is the condition for maximum efficiency? Can anyone type in the chat box? Yes, yes. Can anyone type in the chat box? The condition for maximum efficiency is copper losses must be equal to iron losses. The condition for maximum efficiency is copper losses must be equal to iron losses, but not iron losses is equal to copper losses, but not iron losses is equal to copper losses. This is wrong. That is wrong. Why? Copper losses are variable. If you change the load, what is copper loss? I square R. If it is single phase transformer, I square R. If it is three phase transformer, 3I square R equivalent. Means primary side copper loss will be there, secondary side copper loss will be there. We refer entire secondary to primary or entire primary to secondary. So copper losses must be equal to iron losses. But now how much is the copper loss? 250. How much is the iron loss? 150. Sir, shall we increase iron loss to 250? No. That is not going to happen. Iron losses are not going to depend on the load. So you make copper losses to 150. How copper losses can be changed? If you are changing the load, so change the load so that the copper loss is going to be iron loss. Now copper loss is going to be iron loss. Now what is the total? See, at maximum efficiency, at maximum efficiency, yes, total loss is equal to total losses is equal to iron losses plus copper losses. But iron losses are 150 only. But at maximum efficiency, copper losses must be equal to iron losses. Now, how much is the copper loss? 250. But that must reduce to 150. Then only maximum efficiency you are going to get. That is 150. That is exactly equal to 300 watts. Answer is 300 watts. Option is C. So some people may tick for 500. Sir, if you get 500, if you follow this one, iron losses is equal to copper loss. This is wrong, because these are the fixed losses. These are the fixed one, and copper losses are variable one. Right? Copper losses are variable. Clear? Am I clear? Right? So if you follow this one, no, readily first option is available 500, which is going to give you wrong answer. Right? The next question, please. Next question. Yeah. The maximum flux in a transformer is 5M, okay, when primary voltage is V, okay, and the frequency is F, fine. If the primary voltage is 2V and the frequency is F by 2, the flux will be, see, let me write E, induced EMF E is equal to 4.445 mF into T. This is the induced EMF. Suppose if you are talking about primary induced EMF, this will be E1, this will be T1. See, E1 is the primary induced EMF. I'm taking 1. 1 means primary, 2 means secondary. Okay, 5M is the maximum flux density, F is the frequency, T1 is the primary number of turns. Suppose if I'm taking this one as 2, then this will be secondary number of turns. Transformer is a constant flux device. Primary side flux, secondary side flux, both are same if we are neglecting leakage flux. Okay, I'm not considering all this stuff, leakage flux and all. Constant frequency device it is. Transformer is a constant frequency device. Its frequency is not going to change from primary to secondary. Now from this one, if you see 5M, yes, is directly proportional to E by F, I can write. Why? This T2, say this number of turns is constant. 4.44 is constant. For the given data by him, 4.44 is constant. I can write from here that E, I'm not writing 2 or 1. E is directly proportional to 5M into F. That fellow question is asked about 5M. That is 5M is directly proportional to E by F. Can I write it as 5M1 by 5M2 is equal to E1 by E2 into F2 by F1. E1 by E2 into F2 by F1. Now he is asking about flux 5M2. Here itself I'm doing 5M2 is equal to, I want this one. Therefore, what it is going to happen? 5M1 into E2 into F1 by E1 into F2, right? E1 into F2. I'm writing here. Observe here carefully. So 5M2, 5M1 is 5M, that fellow given, into E2. What is the voltage? 2V. Yes, 2V. By E1 is V. And frequency F1 is F only. But F2 is F by 2. This gone. Therefore, 5M2 is equal to, how much it is? 4 times of 5M1. 4 times of 5M1. Option is A. Just that is a simplification only. Okay, once you understand this relationship, this relationship. After that, only simplification. HPCL exam date, yeah, it is on August 19th, no? August 19th or 18th. I didn't remember exact. I just I forgot that is 18th or 19th. It is already announced, ma. Who is this Max? Yeah. Date you can check online also. It's a computer based test. It is, I think, on August 18th or 19th. I didn't remember. Yeah, 18th of August. Harshvardhan, thank you. 18th of August. Okay. Let's go to the next question. See, we have auto transformer also in syllabus, auto transformer and normal transformer. In an auto transformer, output voltage is always same as input. If that is the case, what is the purpose of transformer? First of all, less copper is used. Yes, because in auto transformer, see, either step, there are two types of induced EMFs. One is because of induction, another is because of conduction. Therefore, the amount of copper required in auto transformer is less than two winding transformer of same power rating, same voltage rating, right? Next, voltage regulation is better. Yes, voltage regulation is better. Therefore, both B and C are correct. For an auto transformer, both B and C are correct. Yes. Harika, yes. Tech Vijay, yes. 18th August it is. Next question, please. Open circuit test on transformer is conducted to obtain. Yeah, on transformer we will be conducting two tests. One is normal test, normal, okay, regular test, I can say. There are a number of tests. Type tests are there, tan delta test is there, Sampanna test, special test, Sampanna test is there, okay, back to back test, open delta. There are many. Open delta is a connection, not a test, please. Okay, open circuit test and short circuit test. The purpose of open circuit test is to obtain core losses or constant losses. The purpose of short circuit test is to obtain, yes, copper losses or variable losses or I square R losses. Main purpose of this open circuit test and short circuit test is to develop the electrical equivalent circuit of transformer, right? The leakage impedances, no. The ohmic loss, no. See, ohmic loss is given by short circuit test, SC test, not OC test. Hysteresis loss only, no. Yeah, we will get hysteresis loss also, but core loss. What is core loss? Hysteresis loss plus eddy current loss. Total core loss, that is core loss. Total core loss, hysteresis loss plus eddy current loss. With OC test, with open circuit test, we are finding core losses, not copper losses, please. Core losses are constant losses. Core losses are constant losses. Or see, those that is nothing but a core loss. That is nothing but the combination of hysteresis and eddy current loss, right? Yeah. Next question, please. Next question. Yeah. So this one we already saw in power system. Power system, zero sequence network of a transformer. I'm saying again, all these are previously asked PSU questions. Okay, what is saying? Following figure report represents the zero sequence network of a transformer, which is connected in. You know, the zero sequence network of a transformer is there is a series switch. Yes. Secondary side series switch and primary side shunt switch. Secondary side shunt switch. This is the zero sequence equivalent circuit. Now, when this series switches will be closed, if for see series switches will be operated for star by star, for star. Okay, series switches are open means it is not star. Both the shunt switches are closed. Shunt switch is closed, primary side delta. Secondary side also shunt switch is closed. Secondary side is also it is delta. The answer is delta by delta. Option is D. Delta by delta. Option is D. I came to your channel for the first time, sir. Daily you teach at 4 p.m. See, I'll be telling you, in fact, almost not on daily basis. Tomorrow we are not having. Day after tomorrow again we are having at 4 p.m. 4 p.m. onwards will be having. So next schedule will be given that day of class. Mostly I'll take daily, but sometimes one day will be skipped in between, right? Yes. So delta by delta it is. Next question, please. EMF per turn. I'm waiting answer from you guys for this question. This is a very good question. This is a very good question with proof. Proof means don't think that's something big. It is a very simple thing. I'm going to take up. I'm expecting answer from you guys for this question. I'll read the question. EMF per turn in HV winding is more than EMF per turn in LV winding. Both the winding have equal EMF per turn. HV winding is less than the EMF per turn in LV winding. Option D is all of the above. Yes. Harika already given the answer as B. Anyone? Harshavardhan, take Vijay, and this person Max. You people can answer for this question, then I'll go forward. I'll give my explanation. Yes, Harika already given the answer. Yes, please. I'm waiting for your answer. Only one person given the answer. Very easy question. Very easy question. Okay. Even if you don't know, also please try to remember. I given previously one formula, that is EMF on primary side. E1 is equal to, what is that? 4.445 F N1 number of turns on primary. Then what is EMF per turn? EMF per turn is equal to EMF per turn is equal to EMF by total number of turns. That is equal to, what is that is? 4.445 M into F on primary side. Secondary side, what is the EMF? E2 is equal to 4.445 MF 5 MF N2. When it comes to this side, E2 by N2 is equal to 4.445 MF. This is equation 1 and this is equation 2. This is the EMF per turn. What is total EMF? E. What is EMF per turn? You have to divide the EMF with the number of respective turns. If you are on the primary, you have to divide with N1. If you are on the secondary, you have to divide with the N2. Right? Now, you see, then both are equal. 1 is equal to 2. EMF per turn on both primary side and secondary side are equal. So both windings have equal EMF per turn. Both windings will have equal EMF per turn. Very good, Mr. Max. Okay. Next question. Yeah, CVT. Please do remember this one. This is used in power system protection. In fact, CVT, capacitive voltage transformer. Capacitance voltage transformer is used to improve the power factor of the transformer. No, power factor can be improved by shunt capacitor or synchronous condenser. These things are there, right? In power system. See how to, if some question, if you don't know how to get the answer with the elimination, I'm teaching here. Now, next, reduce losses in a transmission line. If you want to reduce losses in a transmission line, I told you the methods. See, you go with bundle conductors, resistance will be decreased, right? So that way we can go for reduction in loss in the reduction of loss in the transmission. See, we are increasing the voltage. We are stepping up the voltage to very high values because of two reasons. The primary reason is to improve the stability. Secondary reason is to reduce the transmission losses. With connection of transformer in the transmission line, this capacitive voltage transformer losses are not going to reduce. This is also not correct. Then connect instruments and relays on the LT side, keep it aside. Last option is reduce the incidence of over voltage surges. See, this is also not correct. That is also not correct. The option is B. Please do remember, capacitive voltage transformer or capacitance voltage transformer is used for the connection of relays on the low voltage side of the transformer. Low voltage side. Okay. Next question, please. Yeah. Negative voltage regulation of a, first of all, of a transformer. What is the voltage regulation of a transformer? Percentage voltage regulation is equal to percentage R into cos phi R plus or minus percentage X into sin phi R. Okay. Please do remember this formula. Please do remember this formula. What is percentage R? Percentage R is resistance of, in fact, percentage resistance of transformer. Yeah, transformer is going. Here a lot of questions will rise. Sir, it is primary resistance or secondary resistance? In fact, if you refer secondary to primary or primary to secondary, you get something. Then that one you divide according to the. If you are in the primary side, you have to take the primary base. If you are in the secondary side, you have to take the secondary base. Then if you multiply with 100, you are going to get percentage resistance. Either you do at the primary side or secondary side, answer percentage R will remain same. Okay. Next, percentage X is yes, percentage reactance of transformer. What is that? Percentage reactance of a transformer. Then cos phi R is the name itself. Cos phi R is load power factor. What is that? Load power factor. If you know cos phi R, sin phi R you can easily get. If you know You know the relationship sine square phi r plus cos square phi r is equal to 1. If you know cos value, you can get sine value. Or from cos, if you have suppose a cos is some value, sine easily you can get, right? If cos phi r is 0.8, sin phi r will be 0.6, right? That much easy for us. Now here one thing is very important. I given two symbols plus for, yes, you have to use the plus symbol for lagging loads. For what loads? For lagging loads, yes, and minus for leading loads, minus for leading loads, right? Minus for leading loads. So when this is having chance of becoming negative, suppose if plus is there in between these two, never it is going to be negative. If plus is there, see x and y, x is positive, y is positive. If you are adding these two, your number is going to be still positive, it will increase. But x minus y, if I take, if y is greater than x, x minus y, if y is greater than x, then obviously it is going to be negative. For that one, it should have minus. X plus y, see x and y are both are positive, keep it aside. If I take x plus y, the number will be positive only. If I take x minus y, and if y is greater than x, there is a possibility for that one to be negative. Regulation is going to be negative for what loads? Capacitive loads. For inductive loads, it is going to be plus. Inductive load means what load? Lag load, lagging load. Inductive load means what load? Lagging load. Resistive load means cos phi r is equal to 1, unity power factor it is, unity power factor it is, UPF. So if power factor is unity, cos phi r is equal to 1, sin phi r is equal to 0, obviously. Yes, resistive and inductive, no. For resistive and inductive also, it is going to be plus only. Resistive, capacitive, it will be minus. So for capacitive load, yes, we have the chances of getting voltage regulation as negative. Next question, please. Yeah, voltage regulation in a transformer is always positive at all. See, it is always positive. Yes, lagging power factor load, zero power factor load, lagging and unity power factor load. Yes, for all lagging and unity power factor loads, it is going to be positive. See, yeah, percentage r cos phi r plus a percentage x sin phi r. If your load is lagging, this will be plus, and if it is resistive, anyhow this will be 0, because resistive UPF load, cos phi r is 1, sin phi r is 0. If this part is 0, we have nothing to do with the sign also. So for all lagging and unity power factor loads, it is going to be, for lagging and unity power factor loads, it is going to be, yes, positive, right? Next question, please. Yeah, for this question, I'm expecting answer from you guys, from all of you. I'm expecting from you, please do this question, please do this question, all of you, and answer me. I'm waiting for you. Yes, yes, Harika, Harshvardhan, Tech Vijay, Mr. Max. Yeah, what is the question? If frequency of a transformer is increased by 3 times, maximum flux density in the core is flux density. He's asking about B, flux density B. He's asking about flux density B. Yeah, Harika given the answer. Yeah, I given you that E is equal to 4.44 flux. What I do is I'll multiply with the area and I divide with the area. Yes, any objection? Into F into number of turns. So this is the flux density Bm, maximum flux density Bm. So I can write that E is equal to 4.44 Bm into F into A into T. So E is directly proportional to Bm into A, sorry, Bm into F. Bm into F. What that fellow says, if the frequency is increased by 3 times, frequency, so can I write Bm is directly proportional to E by F or V by F. So Bm1 by Bm2 is equal to, yeah, E1 by F1 into F2 by E2, right? Now bm1 by bm2, right? So what is bm2? Bm2 is equal to bm1 into E2F1 by F2 into E1. He did not given any data regarding EMF, therefore the applied voltage is constant. Applied voltage is constant, just he is varying the frequency. And that fellow says frequency is increased by 3 times. F2 is 3 times of F1. So F1 gone. So we got BM2 is equal to BM1 by 3 times. It is decreases by 3 times. It is decreases by 3 times. Only Harika given answer. What happened? Tech Vijay, Max, Mr. Max, and Harshvardhan. What happened to you guys? Right? You have to answer. Next question, please. Next question. Any auto transformer on no load draws current at a poor power factor because it acts like a capacitive load. It draws only core loss component of current. It draws mainly magnetizing component of current. It draws only magnetizing current. It draws core loss component of current and magnetizing component, both. It acts like a capacitive load. No. It draws only core loss component of current. No. It draws mainly magnetizing component of current. It draws only, yeah, option C is correct. See, under no load, transformer is going to draw two components of currents. Total current is called as no load component of current. That no load component of current is a combination of no load loss component of current IW we call general representation, and the magnetizing component of current I mu. So no load current of a transformer I naught is the vector or phasor summation of I mu and IW. But this I mu is much greater than this IW, mainly this magnetizing component of current. That's why its power factor is poor. Means if you ask me to draw, see, I will draw like this. This is flux phi, I can say, and see, this is the applied voltage V you can take, and I can say, yes, this is I mu, and this is going to be IW. Yes, now this resultant is I naught. This is the angle phi naught, no load power factor angle. Then cos phi naught is no load power factor. If more is the angle, less will be the cos. Yes, cos is a function like if cos 0 is 1, cos 90 is 0 again. Means for cos, if angle is increasing, that value is going to decrease. Clear? That value is going to decrease. Clear? Observe here, please. So phi naught is more. Suppose if magnetizing component of his current further increasing, now this will be the current with the resultant. Now further angle is increased, further power factor is going to decrease. So it draws mainly magnetizing component of current. It will draw, I can say, that working component of current or loss component of current. But the power factor is poor. That fellow asked, why the power factor is poor? Because of that magnetizing component of current mainly, right? Let's go to the next question. The eddy current loss, does not depend upon of the following. What is eddy current loss formula? That is some K into B max square into F square into T square into V. Yes, F square into T square into V. That is eddy current loss formula in a transformer. K is some constant. B max is the maximum flux density. So eddy current loss is going to depend upon K is a constant. This is flux density. This is frequency. T is thickness of laminations. T is thickness of laminations. How small the thickness of the lamination is, that much less eddy current loss is going to happen. What is V, sir? V is not the voltage, it is the volume. Okay, V is not the voltage. So it depends on the flux density, it depends on the frequency, it depends on the lamination thickness, but it is nothing to do with the voltage. Nowhere here the voltage is there. Yes, in the formula, nowhere here the voltage is there. In fact, this B max is going to have that B max is equal to, is directly proportional to V by F, but we'll make this one as constant. We'll make this one as constant. He is not saying I'm increasing F, decreasing V, like that he is not saying. that is V to F ratio. That is V to F ratio. It is not going to depend upon the voltage. Harika, good. And Achur Rock, good. Next question, please. Which of the following is the advantage of using CRGO steel in transformer? Yes, transformer core is made up of CRGO steel. What is the advantage of making transformer core with CRGO steel? Please tell me the answer. See, what is CRGO? Cold rolled grain oriented steel. CRGO steel means cold rolled grain oriented steel. High magnetic flux density, low permeability. If low is the permeability, that is useless for me. What is permeability? Permeability is the ability to allow magnetic flux lines through it. Permeability. If less is the permeability, that is useless for me. Both A and B. No. High magnetic flux density. Yes. CRGO steel is going to have good high magnetic permeability. Therefore, it is reluctance is less. If more magnetic permeability, reluctance is going to be less. Therefore, flux density is going to increase. Flux density is going to have more value. Therefore, we are that's the reason why we are preferring this CRGO steel, right? Yeah, Mr. Max, yes, you're right. Next question, please. The core flux of a practical transformer with resistive load. Yes, sir. That fellow saying load is resistive. There are types of loads: resistive load, purely inductive load. Purely inductive load is called as ZPF lagging load. See, resistive load. This is resistive load. This is called as ZPF lag load. Zero power factor it is. Why? There is no resistance. Obviously, power factor will be zero. And this is ZPF lead load. ZPF leading load. ZPF leading load it is, right? This is UPF load, and this one is called as lag load, not ZPF, but still it is lagging load because of inductive nature. This is lagging load, and this is called as lead load. This is called as lead load, right? Leading load. Now the question is, yes, anyone answered? Harika, given option as A. Yes. The core flux of a practical transformer with a resistive load is strictly constant with load changes, increases linearly with load, increases as the square root of the load, decreases. See, I told you in the very beginning, transformer is a constant flux device. Irrespective of the load, its flux is going to be constant. Its flux is going to be constant. Transformer is a constant flux device. Option is A. Option is A. Let's go to the next question. Please read this question and try to answer. Try to answer. Read the question and try to answer, please. What that fellow says, the induced EMF, electromagnetic field, in a transformer secondary will depend on frequency of supply only, number of turns in the secondary only, frequency and flux in the core, frequency, number of secondary turn and flux in the core. Option D will serve the purpose. Okay, option D is going to be perfectly suitable. E is equal to 4.445 ft. So that is called as EMF equation of transformer. Please, not only for transformer, the same equation is equally valid for induction machine and synchronous machine. In fact, for DC machine also it is equally valid. But in DC machine, in the place of frequency, we are going to replace with something. So in fact, I can say that E is equal to 4.445 ft is the universal EMF equation. But some changes we have to make according to the type of the machine. According to type of the machine. Option is D. Option is D. Next question, please. The function of oil in a transformer to provide. Yes, what is the function of oil in the transformer? Yes, in the transformer we are providing with the oil. On the about the oil of the transformer, number of questions were asked in 2023 paper. Number of questions. Synthetic oil or mineral oil is used. Synthetic oil or mineral oil is used in the transformer. What is the purpose? What is the purpose? Insulation and cooling, protection against lightning. See, protection against lightning, nothing it is going to do. Okay, protection against short circuit, no. Oil is not a protecting one. Lubrication. See, where lubrication is required if there is some rotating electrical machinery. See, if there is something like this and it is rotating, there is friction will develop. Okay, if you take any motor, shaft is rotating, and you are putting shaft somewhere here. So between these two bearings will be there. friction will develop. Therefore I have to put some lubrication so that it will be means if you provide good lubrication, then that I can say mechanical loss, friction, wear and tear is going to be less, right? So answer is to provide insulation and cooling, both the purposes it is going to solve. It is going to provide us both insulation and cooling. Next question, please. The core of the transformer is laminated. Yes. What is the purpose of laminating the core of a transformer? To reduce eddy current losses. Previously we saw the formula, that is T square, where T is the thickness of the lamination. If lamination thickness is low, then eddy current loss is going to reduce, right? Thickness of the lamination. We are laminating so that eddy current loss will be decreased. Eddy current loss will be decreased to reduce copper loss. Copper loss is nothing to do with the lamination and all. It is I square R. This R is not core resistance. That R is winding resistance. Okay. Now to reduce hysteresis loss, no. To reduce magnetic leakage, no. To reduce eddy current losses, with laminations, eddy current loss will be decreased. All these are previously asked PSU questions. Okay. Next question, please. Yeah, do this question, please. All of you do this question and let me know the answer. This is the numerical. I think only the numerical I have taken. If frequency is changed from 50 Hz to 60 Hz in a transformer, the ratio of eddy current losses at 50 Hz and 60 Hz at constant voltage, that fellow saying that voltage is maintained as constant. Okay. Frequency is changed, voltage is maintained as constant, then the eddy current, he is asking about eddy current loss. Answer, please. Yes. I'm waiting. Yes, Harshvardhan saying option as B. Let us see. See, eddy current loss formula I given previously, that is directly proportional to B max square. What is B max? B max is what? V by F whole square. So from this one I can say eddy current loss is inversely proportional to frequency square. So from that one I can say WE1 by WE2 is equal to F2 by F1 whole square. F2 by F1 whole square, right? So if the frequency is changed from 50 Hz to 60 Hz in the transformer, the ratio of eddy current loss at 50 Hz, okay, he's asking about WE1 by WE2 only. So how much is F2 is 60, how much is F1 is 50 whole square. So 0 gone. So how much it is? 36 by 25. See, he is asking at WE1. See, those having confusion, I will teach in the next page. Eddy current loss is directly proportional to B max square. Eddy current loss, B max is nothing but V2F. I already taught you. So eddy current loss is inversely proportional to frequency square. So WE1 by WE2 is equal to F2 by F1 whole square. WE1 is the eddy current loss at 50 Hz. WE2 is the eddy current loss at 60 Hz. So from that one we got 60 by 50 whole square, that is equal to 36 by 25. Yeah, this kind of small mistakes you people will commit. Okay. Yes, class ka time kya hai sir? 4 p.m. na? Yeah, in yesterday's class Ashish got say, in yesterday's class itself I announced that it's not B, it is D na, Ashish, it is D. Ashwardhan, you got the clarity? Yes. Yeah, Ashish, I told you already, class timing is 4 p.m. Okay. Yeah. Understood? It is 36 by 25. Yes. Let's read this question and answer. In a certain loaded transformer, the secondary voltage is 1/4 of the primary voltage, means E2 is 1 by 4 of E1. E2 is 1/4 of the primary voltage. The secondary current is, yes, very simple question, very simple question. Yeah, we know that transformer is a constant power device, constant kVA. So we know that E1 I1 is equal to E2 I2 for a transformer. E1 keep it as E1 only, I1 keep it as I1 only. E2 is 1 by 4th of E1 into I2, even gone, sorry, even gone. So I2 is equal to 4 times of I1. See, you know, it is a constant kVA device or power device. You tell me, if voltage increases, current has to decrease. Therefore, this product should remain constant. This product should remain constant. That product should remain constant. Clear? So 4 times of the primary current. This is, you know, dead easy questions. All are easy questions only. Okay, all are easy questions only. See, this is about transformers. Again, we'll continue. See, this is the phase 1, easy questions from PSUs. Phase 2 of the transformers, I'll be discussing questions on questions and concepts. See, in this video, I not only discussed the questions, I discussed the concepts also. In fact, I discussed concepts, not just the questions. So what my point here is, first phase, easy questions. Second phase, some moderate questions. Third phase, some tough questions. I'm going to discuss. So machines, next machine video, next machine class will be, I'll let you know, but a day after tomorrow at 4 p.m. again we have class. In that I'm going to take up networks. Okay, last class was power system, yesterday's class was power system, today it is machine. Next class, that is day after tomorrow at 4 p.m. on the same channel at 4 p.m. it will be on networks. After networks again I'll resume with power system, then machine. This cycle keep on repeating. Okay, so if you have any questions, you can message me or call me on this number. Yes, this is my contact number. Please make a note of it. If you have any queries, you can directly contact me. Fine. See, YourPedia launched a very good module only in the direction of HPCL. Okay, we are not teaching any unnecessary things. Okay, depending on the syllabus, depending on the previous papers of HPCL, just we are teaching exactly in the direction of HPCL. Okay, so if any one of you interested, you can contact me, right? Yeah. आशीष गार्ड से मराठी में बोलो. सी आशीष गार्ड से मैं हिंदी में बोल सकता हूँ, लेकिन मुझे मराठी तो नहीं आती. ठीक है, आई एम फ्रॉम हैदराबाद, आई कैन स्पीक हिंदी. इफ आप, अगर आपको किसी को लैंग्वेज की दिक्कत है तो आप मुझे बता दीजिएगा, मैं हिंदी में बात करेगा, सो दैट सबको समझ में आएगा. ठीक है, अगले क्लास में हम मिलेंगे. विल मीट इन द नेक्स्ट क्लास. थैंक यू. Yeah, yesterday's video you can find in the channel, Mr. Max. Yesterday's video you can find in the channel. Okay, same channel you can find. Just you type HPCL power system, you'll get. Fine. Yeah. All the best to all of you.